Okay, today we're going to go over a little bit about what we have done third quarter. So we're going to go over a little bit about equations and then the equations of lines. We're going to go over comparing functions. We're going to go over direct variation. We're going to go over what a function is and what a function is not. I'm going to start with direct variation. Okay, to tell if something is direct variation or not, it has to be in the form y equals kx or y equals mx. Where we're looking at the k and the m, that's the slope if you're looking at a table. Something that is a direct variation would be an example of a table that is 1, 4, 2, 8, and 3, 12. To have direct variation, that means that x and y vary directly. That means that x and y have the same ratio. That means that if we look at these two, y over x, then for the first one it would be 4 over 1. For the second one, if you look at y over x, you have 8 over 2, which also reduces to be 4 over 1. And if you look at the third one, you have 12 over 3, which also reduces to be, okay, and 12 over 3 is also 4 over 1. So each time we can say that this has direct variation because each time they have the same ratio. It's going to be 4 over 1. So if we write a equation based off of this, that 4 over 1 is going to be what we're going to put for m or for k. So our equation for this particular table would be y equals 4x. And this is directly related. If we did another example on what is directly proportional, and we had a table that looks like this, okay, if we had this table and we wanted to figure out if this relationship is a direct variation, we would look at each of these yx or xy ratios to make sure they stay constant. If they stay constant, then it's directly related, or it's a direct variation. So we're looking at y over x. So for the first one, it's 45 over 5, which would give us 9. The second one is 15 over 15. And that's going to give us 1. And the third one is 25 over 9, which that's going to give us an improper fraction. So we can already tell by looking at these two ratios that they're not constant. So if they are not constant, when it asks, is this a relationship, a direct variation, we would say no. All right, the next topic that we covered this quarter was what is the equation of a line? So if you have a line that passes through 0, 4, and 4, 0, you can find the equation by looking at the line. We learned that when we write an equation, it has to be in slope-intercept form, where m is the slope and b is the y-intercept. And your y-intercept is where your line crosses through the y-axis. Okay, so that would be at 4. So when we go to write our equation, we could write y equals, we don't know what the slope is yet because we haven't counted, but we do know that the line crosses through the 4 on the y-intercept, so it's at 4. Now to figure out what our slope is, the slope is really rise over run. That's how many you count up or down over how many you count right or left. So from the top point, from 0, 4, we're going to count down 1, 2, 3, 4. So down 4, which that is going to make a negative. And then we're going to count over 1, 2, 3, 4. Over 4. And this is going to make my slope negative 4 over 4, which equals negative 1. So on the board where it says negative 4 over 4 equals negative 1, you know that your slope is negative 1. You don't have to write out negative 1. You can just put a negative x. Okay, we learned about comparing functions. When you compare functions, you can compare them using different representations. So we would compare the function by looking at a table and looking at a graph. When the question says to compare functions, you are really comparing the slope, okay? Because when you compare functions, you're comparing the rate of change, because it asks you what is greater. Or compare the slope. It's the same thing. So when you're using a table to compare functions or to compare the slope, to figure out what the slope is in a table, you always have to take the table and put it into the formula y2 minus y1 over x2 minus x1. And that's going to give you the rate. So you would pick 2 points in the table, which T and D would really be representing x and y. You'd have 0 and 3 and 1 and 5. This is your x, this is your y. x1, y1, x2, y2. We plug them into this formula to figure out what the slope is. Then you can subtract and you find that the slope is 2 over 1. So that would be our rate for that particular table, would be 2 over 1. To find the rate within a graph, you're going to count using what you know about slope and rise over run. So you would find where your graph intersects perfectly, and you would use rise over run. So you'd look at the line of your graph, and you would find 2 points where they intersect perfectly, which I would use 0 and 3 and 2 and 7. And you could do 7 minus 3, 2 minus 0. 7 minus 3, you get 4 over 2. And then your rate for this one would be 2. So if it told you to compare the functions, you would look at your table and you would find that the slope for the table would be 2, and then you'd look at your graph and you'd find that the slope for the graph would be 2. So in both of these, the slope or the rate of change is 2, so when you compare the functions, you can say that the functions are the same, because they have the same slope. Okay, when you're comparing whether they are linear or nonlinear functions, we learned that linear functions, when you're looking at an equation, are in mx plus b form, if it's linear. On a graph, linear equations make straight lines. Nonlinear equations are equations that have exponents. And their graphs are not straight lines. Linear just means straight line. So the word line is inside of that linear word, so that means straight line. We also learned what is a function and what is not a function. What is a function is that in a table, every x has one y value. What is not a function, an example of a table that's not a function would be if I had x and y. Okay, on the right, the black table is what is not a function, because you can see that every x does not have one y value. Over here, x has 4 for a y value, but then it also has 2 for a y value. So this means that this would not be a function, because x cannot repeat with 2 different y values. On a graph, an example of what is not a function would be if you use the vertical line test. If you draw a vertical line through what is graphed, say that what is graphed is the black parabola, we draw a vertical line through this, our vertical line will touch what is graphed 2 times, so that's not going to be a function. So in order to be a function, it has to pass the vertical line test. So if I made another graph, and had my graph, put a vertical line through my graph, my orange line only touches the black line once, so this would be a function. So to be a function, it must pass the vertical line test, only touch once. It can only touch once. Another topic that we learned about this quarter was parallel, perpendicular, and lines that are neither. So we studied equations like the equation y equals, let's say, 5x plus 5. If we wanted to find a line that was parallel to the line y equals 5x plus 5, we learned that parallel lines have slopes that are the same. So we can come up with an equation of a parallel line to y equals 5x plus 5. So all we're going to do is write an equation that just has the same slope as 5x. So the slope is 5x, so we're just going to write an equation 5x plus, let's say, 2. Now I could pick any y value, which in this case I just picked 2. I can pick any y value except for 5. Because if I were to pick y equals 5x plus 5, just like my red equation, that would give me a line that was the same exact line, or a line that was coincident. Coincident lines mean that it's the same line graphed on top of the same line. So if I wanted to find a line that was perpendicular to the line y equals 5x plus 5, I know that the slopes for perpendicular lines are negative reciprocals. That means that if my slope is 5, my slope is actually 5 over 1. And a negative reciprocal would mean that I would make it negative, but then the reciprocal would mean that it would be flipped. Instead of 5 over 1, I would do 1 over 5. So then I could write in the equation y equals negative 1 over 5 x. I could also use plus 2. Now for this one, I could put plus 5 and the lines not be coincidence like they were if they were parallel, but I'm going to use plus 2 instead. So if I want to come up with a line that intersects with this, if I wrote y equals any slope, it didn't matter what it would be, I could put 2x. As long as I put the same y-intercept of 5, I know that these are going to intersect, my two lines will intersect at 5 because they have the same y-intercepts. So parallel lines have the same slope, perpendicular lines have opposite, which reciprocals, and they're the opposite signs, and then intersecting lines have the same y-intercept. Okay, we also learned the vocabulary behind x and y. So when we're talking about y values and x values are also called input, y values are called outputs, x values are called domains, y values are called the range, x values are called independent, and y values are called dependent. We also learned about writing equations. If we had a word problem like Brandon babysits for Miss Boland, she gives him $5 in gas to come over and babysit. And she pays him $3 per hour. If I told you to write an equation that best represents how much money he earned babysitting, you know that our equation would be y equals mx plus b, where b would be our initial value or set fee. So b would be $5, because that would be the set fee that he gets to babysit. If he shows up to babysit, he automatically gets $5 for gas. Now the rate we know would be the slope. That's the rate per hour. So his rate per hour would be $3. So we learned how to write equations using the rate and the initial value or the set fee. So we could use this equation to figure out the total amount that he makes babysitting based off of how many hours that he worked. We also learned about distance time graphs, where time is your x and distance is your y. We learned that these graphs represent the rate of change, and we learned that we had to describe the graphs. So as you can see in this graph, it shows that Tom rode his bike and then he jogged or walked. So in the first interval, this blue line represents a faster rate. Okay, the second interval represents slowing down. And since the distance is going negative, the third interval represents him going back to where he came from. So we would have to figure out one of these little scenarios where he went faster and then slowed down and then went back to where he came from. So you would read through each scenario to find which one matched the graph below. The best scenario that this represents in the graph would be that Tom went for a jog because he had a faster rate. At the end of his road, he bumped into a friend and his pace slowed, which you can see with the green. When Tom left his friend, he walked quickly back home. So since his distance is negative, that means that he's going back to where he came from and that he's walking back home. So C would be the best answer. So now you have all the information that we've reviewed for third quarter, so you can be successful on your third quarter exam. Good luck to you guys.